Alright, now let's have a look at the solutions to part of the questions in topic 8a. Okay, first question, we're going to have a look at M. If A is less than B, C is less than D, what is the relationship between A minus C and B minus D? Well, actually, this cannot be determined, right? Because you don't, A and C are the smaller numbers. And the difference between A and C is not necessarily larger than or smaller than or equal to B minus D, right? For example, if we know 2 is less than 4, right? And 1 is less than 5. And if you let A equals 2, B equals 4, C equals 1, D equals 5, then A minus C is 2 minus 1, right? And B minus D is 4 minus 5. We know that 2 minus 1 is 1, and 4 minus 5 is negative 1. So you should put a larger than here, right? Otherwise, you could also let A equals 2. 2 is less than 4. And this time we could keep other numbers unchanged, but let D equals 2. And in that case, A minus C is still 1 minus 2 minus 1, which is still 1, right? But here B minus D is 4 minus 2, which gives you 2. So you should put a smaller than here. Or we could also keep everything unchanged, but let D equal 3. In this case, A minus C is 1. B minus D is also 1, right? So we can also put an equal sign here. Therefore, the relationship between A minus C and B minus D cannot be determined. Okay, and next let's have a look at question number 5. Okay, which number is larger? So in order to compare the two numbers, we could raise them to the power of 6, right? So we know that number on the left raised to the power of 6, and then the number on the right is raised to the power of 6. So we don't know which sign we should put here, right? But this does not change the direction of the inequality sign. And then the left side gives us 3 cubic root of 5. The right side is 6 square root 2 to the power of 2, right? And we still there is a power 3 here. And if you can't see the relationship between these two numbers, let's simplify this. The left side gives us 27 by 5. The right side is 36 by 2, right? Apparently, the left side is larger than the right side. Therefore, note that in each step we did not change the direction of the inequality sign, right? Therefore, we know the number on the left side is larger than the right side. Therefore, we have this number is larger than this one, right? Okay, next it's number 6. Question number 6. Which number is larger? Again, compare two numbers. So note that we have two positive integers, right? So in order to compare them, the number on the left side can be rewritten as 2 to the power of 8, then to the power of 9, times 2 to the power of 9, right? The number on the right side can be rewritten as 3 to the power of 5, then to the power of 9, times 3 to the power of 4. Then the left side gives us 256 to the power of 9 by 2 to the power of 9. The right side gives us 243 to the power of 9 times 3 to the power of 4. And then the left side is 256 to the power of 9 by 512, right? The right side is 243 to the power of 9 by 81. So we know this number is larger than this one, and this number is larger than this one. So we should put a larger than sign here, right? And in each step, it did not change the direction of the inequality sign. Therefore, we know 2 to the power of 81 is larger than 3 to the power of 49, right? Did you get it? Any questions? Okay, next one, question number 8. Solve this inequality. Okay, this is a system of two inequalities, so let's solve these two inequalities, then combine the final result together. So from the first inequality, we have 5x is larger than 15, right? Which gives us x is larger than 3. From the second inequality, we have x plus 1 is larger than or equal to 3, which gives us x must be larger than or equal to 2, right? And therefore, we know, if you consider both cases here, the final result is overlapped area of these two solutions, which is the larger one, right? So final solution is x is larger than 3. Well, if you cannot see that immediately, then you can use a number line to help you to find the final solution. So x is larger than 3 is here, the interval to the right side of number 3. And we know 2 is here, right? So x is larger than or equal to 2 is the interval here, to the right side of number 2. And note that we use solid dot to indicate the left side of that interval is included in that solution. And of course, the overlapped area is here. Therefore, the final solution is x is larger than 3. You get it? All right. If no questions, let's have a look at question number 9. Again, we could solve them separately and combine the two intervals. From inequality number 1, we have 5x is smaller than or equal to negative 20, which gives us x is smaller than or equal to negative 4, right? From the second inequality, we have 2x is smaller than negative 6, and this gives us x is smaller than negative 3. And of course, if you cannot see that final solution, you can also use a number line to help you to find that. First solution says x is larger than or equal to negative 4, which is to the left side of negative 4. Negative 4 is included here. Second solution tells us that x is larger than, x is smaller than negative 3, which is to the left side of that number here. Again, the interval that can satisfy both of the two solutions is x must be smaller than or equal to negative 4. This is our final solution, right? Any questions? All right, if no questions, let's have a look at question number 13. Okay, again, we can solve these two inequalities separately and then combine the result from inequality number 1. This actually gives us two inequalities. First of all, we have 10x minus 15 must be greater than or equal to 0. And we need to ensure also 10x minus 15 is smaller than or equal to 23. And which gives us, first of all, x must be greater than or equal to 3 over 2, right? And at the same time, we also need to ensure x is less than or equal to, well, this time we have 38 over 10, which is 3.8, right? So here, let's use decimal as well here, which is 1.5. Okay, so from the first inequality, we have x is larger than or equal to 1.5, less than or equal to 3.8, right? From the second inequality, we have, well, if the absolute value of a number is larger than 1 over 2, we have x minus 5 over 2 is larger than 1 over 2, or you could also have x minus 5 over 2 is less than negative 1 over 2, right? And from the first inequality we have x must be larger than 1/2 plus 5 over 2 is 3. From the second inequality here we have x is smaller than 2. So from the second inequality we have x is larger than 3 or x is smaller than 2. Again, we need to find an interval that can satisfy both of the solutions. First, note that we have 4 numbers here, right? You can use the number axis to help you to find the corresponding intervals. So this is 1.5, then this is 2, and we also have 3, and then 3.8. The first solution tells us that x must be between 1.5 to 3.8, right? From the second inequality, we have x is larger than 3, which is to the right side of 3 here, or x is less than 2, which is to the left side of 2. Therefore, we can easily see that the overlapped area is here or here, right? Therefore, we know the solution is x is greater than or equal to 1.5. Okay, final solution, x is larger than or equal to 1.5 and less than 2. Or there is a second interval that can satisfy this system, which is x is larger than 3 and less than or equal to 3.8. You see that? Okay, and question 14. Solve this inequality. Okay, so here this inequality tells us that x squared must be less than 9, right? If you have x squared is less than 9, then x must be between negative 3 and positive 3. Do not forget the left side. You get it? Okay, if you don't have any questions, let's see the next one. So next one would be question 15. Solve this inequality here. So usually we do not multiply both sides using 3x plus 5 because you're not sure whether the denominator is greater than or equal to 0 or less than 0. Therefore, we don't know if we need to change the direction of the equal sign here, right? Usually we'll put everything to one side. So this gives us 4x minus 5 over 3x plus 5 minus 3 is greater than or equal to 0. Actually, the original equality is equivalent to this inequality here, right? And then we rewrite this inequality. We rewrite the expression on the left side using the common denominator, 3x plus 5. Then we have 4x minus 5 minus 3 times 3x plus 5, right? It's greater than or equal to 0. And this is equivalent to 4x minus 5 minus 9x minus 15 over 3x plus 5, greater than or equal to 0. And this is equivalent to, we have then negative 5x minus 20 over 3x plus 5 is greater than or equal to 0, right? And this is actually equivalent to two things. First of all, we could have negative 5x minus 20 over 3x plus 5 equals 0. Or we could also have negative 5x minus 20 over 3x plus 5 is larger than 0, right? So let's label them with 1 and 2. Then we need to solve these two equations or inequality. So from equation number 1, this is actually equivalent to, first of all, if you have a ratio that is 0, that is equivalent to the numerator must be 0 and the denominator cannot be 0, right? And this is equivalent to x equals -4. This is solution from branch number 1, right? And from the second branch we have, well, if you have a ratio that is larger than 0, this is equivalent to say the product of these two numbers must be greater than 0, right? And well, we could then divide both sides using -5 in order to simplify that expression. So this factor becomes x plus 4, then 3x plus 5. Then if you divide both sides using a negative number, we need to change the inequality sign, right? Okay, so basically the left side is a quadratic expression which has zeros, two zeros, which is -4 and -3, -5/3, two zeros, and opening up, right? And therefore, you need to find the interval that makes this quadratic expression be less than 0. Apparently, that's the interval in the middle, right? From here to here, the interval in the middle will make this inequality less than 0. Therefore, it's equivalent to say x must be larger than -4 and less than -5/3, right? And if you combine these two solutions here and here, the final solution would be x is larger than or equal to -4, less than -5/3. Do you get it?
I get it.
Okay, so this is our final solution. Alright, then let's consider question number 16, the last one. Again, the method should be the same with question number 15. Just do not multiply both sides using 2x minus 3 because you're not sure whether it's greater than 0 or less than 0. So you cannot decide whether to change the direction of the inequality sign here. But usually we'll put everything to one side of the inequality. So the original inequality is equivalent to this one. Put 6 to the left side, then rewrite the left side using the common denominator, 2x minus 3. So minus 6 times 2x minus 3 less than 0, and this is equivalent to 4x plus 5 minus 12x plus 18 over 2x minus 3, that is less than 0, and this is equivalent to say we have -8x then plus 23 over 2x minus 3 must be less than 0. So here this is strictly less than 0, so we don't consider the cases where it equals 0. So that's equivalent to say when you have a quotient that is less than 0, this is equivalent to say the product of these two numbers must be also less than 0, right? And of course, the left side is again a quadratic expression, and the leading coefficient a is less than 0, so it's opening up, opening down, right? And there are two zeros. One of them is 3/2, the other one is 23/8. Which one is larger? This one is larger, right? So this is a larger one, this is a smaller one. And then we need to find any interval that makes this expression less than 0. Therefore, the solution is to the left side of the smaller 0 or the right side to the larger 0 here. Therefore, we know x is smaller than 3 over 2, or x is larger than 23 over 8, right? So this is our final solution. Do you have any questions?
No.
Alright, so this is pretty much about it.